Hi everyone, I hope you're doing well. I'm showing you this disease lab simulation so you can see how diseases spread differently when people are vaccinated. So the first disease we're going to look at is this influenza. It's spelled a little differently, I think, just because it's not exactly influenza, but it mimics the flu. So I've got a high population density. I've got 900 people. Each little dot represents a person. The red dots represent someone who has the flu. The green dots, someone who's at risk for getting the flu. And you'll see in a moment, blue dots are people who are immune. They've already gotten the flu, or they've got a vaccination for the flu. So if I just run this simulation with medium population mixing, no one has the vaccine, and we start with 3 people who are contagious. After 100 days, 24 people have died. There were 2,652 sick days. And not even everyone got it. There's a handful of green dots around. But this graph shows us here the contagious, at risk, immune, dead. Okay. So now what happens if we run it with 25% of the people have been vaccinated? Now we got a whole bunch of blue dots here because they got the vaccine. They didn't have to get sick. Now we still have 25 people have died, but we only have 1,881 sick days. And there was a lot less contagiousness if you see this graph here. Now let's try it with 50% of the population vaccinated. So half the people have been vaccinated. All of a sudden now we're down to 3 people dying, only 207 sick days. And you can look at the graph, contagious, it's barely there. Now if we do 75% of the population, 2 people died, 93 sick days. It's a little bit random, but not very many people have gotten sick. And if we do 90%, because remember, not everyone can be vaccinated. Babies sometimes can't be vaccinated yet, or old people, or people who have autoimmune disorders, or people who have allergies to things in the vaccine. So the vast majority of people can be vaccinated, but not everybody. So let's run it as if 90% of the people have been vaccinated. No one died. Only 6 sick days out of 900 people. So right here, we're seeing something called herd immunity. Right? Almost nobody got sick. And that protects the people who can't get the vaccine. So influenza, or the flu, is pretty contagious and kills some people every year. But let's look at something that we've had a vaccine for that you've probably been vaccinated for, and you have to be vaccinated for in order to go to school. They call it measles here, but it's the measles. We've got the same high population density, medium population mixing. We're going to go with no one vaccinated. Almost 60 people have died. 59 people have died. 7,197 sick days. So you can see measles spreads a lot faster. Now let's try it as if half the population's been vaccinated. We went from 59 people dying to 21 people, and by the way, all of these are over 100 days. And we also cut the number of sick days in half. And then not everyone got it here. You see all these green dots? And if we do 90% of the population has been vaccinated, only 2 people died and only 69 sick days. And most of the people who weren't vaccinated didn't catch it. So another example of herd immunity. So I hope this helps you understand why we need to vaccinate most people, even if they're not at risk of dying from that particular disease. Have a great day.